All right, today we're diving into something that is, honestly, completely mind-bending. It's a radical new idea that could fundamentally change how we think about life itself. What if the real engine behind evolution isn't just random luck, but a powerful quantum process that's been running for billions of years?
We all know the classic story, right? Evolution happens through random mutations, tiny accidental changes in DNA. And over these immense stretches of time, natural selection does its thing, and slowly, very slowly, new forms of life emerge. And look, it's a beautiful theory. It makes a lot of sense.
But there's a nagging problem, one that has kept scientists up at night for decades. When you actually run the numbers, did life have enough time for a purely random process to create all the incredible complexity we see around us? Or was there a hidden shortcut, a cheat code? And that brings us to our first major hurdle for the classical theory, what some are calling evolution's impossible speed problem. It's like the timeline of life on Earth presents this massive wall that pure random chance just can't seem to climb. Think of classical evolution as a random walk. Picture a drunkard stumbling around in a gigantic dark maze. He tries one path, hits a dead end, turns around, tries another. It would take an astronomical amount of time to find the exit, but here's the kicker. The fossil record shows life appeared shockingly fast after the Earth formed. And then you have things like the Cambrian explosion, this incredible burst of complexity that happened in a geological blink of an eye. Life didn't just walk, it leaped. So how in the world did life pull this off? How did it make that leap? Well, the answer might be hiding in the weird, counterintuitive rules of the quantum world. This is where we find the quantum shortcut.
So instead of a random walk, imagine a quantum walk. You know that weird quantum idea of superposition, where a particle can be in multiple places at once? Well, a quantum walk uses that principle to explore all possible paths simultaneously. It's not about trying one option after another, it's about trying all of them at the same time, which lets it find the right answer exponentially faster. And this right here is the perfect way to visualize the difference. The random walk, that's the slow, painful slog. One path, dead end, backtrack, another path for eons. But the quantum walk, boom, the entire maze just lights up. Every single path is explored in the same instant. The correct way forward isn't found by trial and error, it's found almost immediately. Okay, so this is where it gets really wild. How does this quantum process work to build life before life is even a thing? We have to go all the way back to the primordial soup to see this quantum leap in action for the first time.
So if I asked you to guess what the raw material for life was, what would you say? You know, maybe something gentle, like water or clay. Well, the actual answer is pretty shocking. Get this. One of the primary ingredients for life was hydrogen cyanide, a deadly poison. In fact, key molecules like adenine, one of the 4 letters in our own DNA, is basically just 5 molecules of hydrogen cyanide stuck together. Life's very first chapter was written with one of the most toxic chemicals around. So here's the first great filter. The early Earth was just getting blasted by destructive UV radiation from the sun. Most organic molecules would have been instantly shredded. But it turns out the specific molecules that make up our DNA and RNA, they have this incredible quantum superpower. It's called photostability. They can take a direct hit from a UV photon and in a flash, turn that harmful energy into harmless heat. So think about that. Physics itself was doing the selecting, picking the most stable parts, long before biology even entered the picture. All right, so the universe has picked out the right Lego bricks. But now comes the really hard part. Getting those bricks to assemble themselves into the first true engine of life, a molecule that could actually make copies of itself. See, a strand of RNA can fold itself into a bazillion different shapes, but only one very specific shape can actually work as a replicator. Finding that shape is like trying millions of different keys in a single lock. But with a quantum walk, forget trying one key at a time. It's like the molecule gets to try every single key shape at the exact same moment. It just snaps into the one perfect, stable form that unlocks the door to life.
And this is so important. This quantum shortcut wasn't just a one-time trick to get the ball rolling. No, this advantage was hardwired into the very first forms of life, creating these incredibly powerful quantum engines.
Just take a look at photosynthesis. It's the process that literally powers our entire planet. It's a process we see every day, but for the longest time, its efficiency was just baffling to scientists. It seemed impossibly good. And the answer, it turns out, is quantum mechanics.
When a plant captures a photon of light, that little packet of energy has to get from the point of capture to a specific reaction center to be used. Instead of bouncing around randomly and losing energy, it uses something called quantum coherence, and it's wild, to basically explore every single pathway to that reaction center at the same time. The result? Almost perfect, 100% efficiency, no wasted energy. It's a perfect delivery system designed by quantum physics. Okay, so this isn't just ancient history. This quantum engine is still running, right now, inside our very own DNA.
We used to think that mutations were just random copying errors, glitches in the system. But there's a quantum effect called proton tunneling, where a proton could just jump from one spot in the DNA to another. Well, this new idea flips that on its head. What if that quantum jump isn't a mistake? What if it's a feature, not a bug? A built-in accelerator that lets our DNA actively and efficiently explore new genetic combinations, speeding up adaptation.
Okay, let's zoom all the way out. We've gone from poison chemicals to photosynthesis to our own DNA. When you connect all these dots, what is the incredible picture that emerges about life itself?
Well, it suggests the entire 4 billion-year history of life could be seen as one long, continuous quantum computation. First, physics selected the hardware, the photostable molecules. Then, a quantum walk found the first piece of software, self-replicating RNA. Next, quantum coherence upgraded the power supply with photosynthesis. And finally, quantum tunneling in DNA gave the whole system an accelerator, allowing for the explosion of complex life.
Which brings us to an absolutely staggering conclusion. A way to think about ourselves that's completely new. You, me, every living thing on this planet, maybe we're not just the product of a series of lucky accidents. Maybe we are the current output of a quantum search algorithm that's been running for 4 billion years. And so, all of this leaves us with a question that is just huge. It changes everything. If the laws of quantum mechanics provide such an elegant and efficient shortcut to creating complexity, then is life just some bizarre fluke that happened to pop up here on Earth? Or is life a fundamental, natural, maybe even inevitable outcome of the laws of the universe itself?